Chapter 9, Section 4 is about compositions of transformations, which just means that we're going to put a bunch of things together. So by the end of this lesson, you should be able to apply theorems about isometries, and then also identify and draw compositions of transformations, and we're going to do something called glide reflections. So remember, there's three types of transformations that we've talked about: reflections, translations, and rotations. A composition is one or more transformation followed by another one. Glide reflections are a translation and a reflection together. So you're going to like slide it across your paper and then flip it over something. So there's a theorem that says a composition of two isometries is also an isometry. So basically all that means is that what we're doing, even though we're going to do more than one of these together, we still get congruent shapes or figures. So a glide reflection is the one that we're going to do most often. A glide reflection that maps JKL to J prime, K prime, L prime is the composition of a translation along a vector followed by a reflection across a line. So we translated the vector, we moved it this much, so each one of these things got moved that much. And then we flipped it over. So you flip over all parts of it, and then this right here is our image. So we're going to do two things to it. So KLM has vertices at KL and M. We're going to rotate it 180 degrees about the origin and then reflect it across the y-axis. So let's graph what we have. +4, -1, and then 5, -2, and then 1, -4. So here's our triangle. And the first thing we got to do is rotate 180 degrees. Now if you remember your rules, remember to rotate something 180 degrees, all you got to do is change the signs on your x's and y's. So K prime is going to be -4, +1. L prime is going to be -5, +2. And M prime is going to be -1, +4. So if we put these on here, -4, +1, -5, +2, and -1, 4. So that's the rotated one. And now we want to flip this across the y-axis. So remember, when something flips across the y-axis, you keep the y values the same, but you change the x values. So K double prime is going to be, keep the y values the same, so that's a 1, but you make that a +4. So change the sign on the x's, keep the y's the same. Change the sign on the x's, keep the y the same. And we should imagine that our shape is going to be somewhere over here in quadrant 1. So K is at +4, 1. L is at 5, 2. And M is at 1, 4. So when we connect these, this red shape right here is our image. That's our answers, everything that's over there. So basically we just did two things to it all in one problem. So let's do a different one. JKL, so same letters, reflected across the x-axis first and then rotate it 180 degrees about the origin. Now you will get different answers depending on the order that you do this in, so make sure you do it in the correct order. So over 1 down 2 is J. Over 4 down 2 is K, and L is 3, 0. Here's my original shape. First thing I want to do to it is reflect it across the x-axis. So remember, if we do something across the x-axis, you change your y's. So our new points are going to be, keep the x's the same, make the y's positive. Okay. should be x is the same, y is positive, L, x is the same, y is positive. So that 0 doesn't move. Because it's on the x-axis, this is also L prime. So then j I'm going to go over 1 up to, k I'm going to go over 4 up to. So here is my in-between shape. And then I'm going to rotate it 180 degrees about the origin. So remember, 180 degrees means that you make your x's and y's both negative. So this will be -1, -2. K will be at -4, -2. And L will be at -3. And 0 you can't make negative, so it's just at 0. So -1, -2. K is -4, -2. And L is -3, 0. So this right here is our final shape. So here's some theorems. The composition of two reflections across two parallel lines is equivalent to a translation. So think about that for a second. If you flip something over and then flip it over again, you get the original image. So this got flipped over and then flipped over again. So this triangle is exactly the same as this one, and now it's just a translation. The key thing is these two lines have to be parallel in order for that to happen. The translation vector is perpendicular to the two lines. So the translation vector is, if I go from this point to this point, same point but on image and pre-image, it's perpendicular to those two parallel lines. And then the length of that is twice the distance between the lines. So whatever this distance is here, this whole distance is twice as big. The composition of two reflections across two intersecting lines is equivalent to a rotation. So I flipped it over this one and then flipped it over another one, and because these two lines cross, it's really just like I rotated this original image. The center of intersection, or the center of rotation, is the intersection of those lines. So 0, 0 is where we usually like it to be. And the angle of rotation is twice the angle measure of the angle formed by the two lines. So whatever this angle is, this that it rotated is double that. And then you need to remember that any translation or rotation is equivalent to a composition of two reflections. That's basically what this is saying. Two reflections equal a rotation, two reflections equal a translation. So let's say Sean reflects a design across line P and then reflects it across line Q. So two reflections. Describe a single transformation that moves the design from the original position to the final position. So here to here, here to here, and here to here. So because he reflected it twice, two reflections equals a translation. And if I want to describe this, they told me the distance between these two parallel lines is 5 centimeters. This translation has to be double that. So translation of 10 centimeters is what will get us to that final position. And remember, that just comes from this theorem, that whatever this distance is between these two parallel lines, double that is the distance the entire shape moved. So you should be able to apply theorems about isometries like we just did, and then identify and draw compositions of transformations when you do one or more things on a graph together. Write down any questions you have and we can go over them in class. Enjoy your night.